Welcome to the Podkey summary of Build with the new Apple Foundation model on private cloud compute from WWDC 2026. Apple's developer story around AI is getting a lot clearer, and the big theme is choice without a lot of extra plumbing. You've got an on-device model for fast, private, lightweight work, and private cloud compute for bigger jobs, deeper reasoning, and much larger context windows. What makes it interesting is how much Apple is trying to hide the usual server model mess from developers while still putting guardrails around privacy, quotas, and user experience. Private cloud compute is Apple's answer to the obvious question. If the model leaves the phone, what happens to the data? The promise is end-to-end privacy, with user data used only for the life of a request and not stored permanently. And Apple says those guarantees have been independently verified by researchers. That matters because this doesn't behave like the usual go sign up for an API and hope your privacy docs are sorted setup. The server model stays inside Apple's ecosystem, so developers don't have to bolt on a separate privacy policy just for an outside LLM provider. From an implementation standpoint, this may be the most frictionless server model we've seen. There are no API keys for developers to juggle, no separate account setup, and no extra user authentication flow, just to reach the model. If the person already has a device that supports Apple Intelligence, the plumbing is basically there. That's a pretty big deal, because a lot of AI integration work is not actually model work. It's account work, billing work, auth work, and all the little headaches nobody brags about. The practical jump is huge on context size. The on-device model tops out at 4 KB, while private cloud compute goes to 32 KB, which opens the door to feeding in much larger inputs like full articles and images together. That larger context also supports more advanced reasoning, and Apple exposes that with 3 levels: light, moderate, and deep. With those reasoning modes, the model generates an internal reasoning segment before the final answer, so it's effectively thinking first and answering second. Deep reasoning can get expensive, though. The reasoning transcript can be longer than the answer itself, which means more tokens and more latency. Developers can inspect that through the session transcript, so at least the token burn isn't happening in a black box. There is a daily quota attached to each user's iCloud account, and developers don't pay for those private cloud compute requests directly. If users want more headroom, they can raise the limit with iCloud Plus, which is a very Apple way to handle scaling. The SDK exposes flags, like is limit reached and near limit, so apps can react before the experience falls apart. Apple's advice here is refreshingly sensible. Don't just throw a hard error on screen. Use persistent UI that explains what happened, disables the request button if needed, and gives the person an upgrade prompt, or at least a clear next step. And if they're getting close to the cap, warn them early so they can choose what's worth spending their remaining requests on. A lot of this gets easier because Apple built a unified Swift API across the on-device and server models. Switching between them can be as small as changing a single line of code in the foundation model's framework. Things like structured output through generable and tool calling work the same way on both sides, so developers can experiment without rewriting their app logic every time they change model strategy. Apple also introduced a Swift-based evaluations framework in Xcode for benchmarking model performance on your actual feature, which is exactly the kind of boring-sounding thing that saves teams from making expensive choices on vibes alone. It gives developers a way to compare on-device and server results objectively, and in some cases the takeaway may be that the smaller local model is already good enough. That's useful, because the best AI architecture is often the one that does less than you expected, not more. The bigger picture is that Apple clearly wants developers to mix both models inside the same app. Use the on-device model for simple or offline tasks, where privacy and speed matter most, and route larger, reasoning-heavy, context-hungry requests to private cloud compute. That hybrid approach lets apps balance privacy, latency, and capability instead of pretending one model should do everything. Apple even added an Xcode debug tool called Simulate Apple Foundation Models Availability, so developers can fake near-limit and limit reach states and make sure their UI behaves before real users ever hit the wall. So the headline here is simple. Apple isn't just shipping models, it's shipping a whole opinionated lane for how apps should use them. And for once, a lot of the most interesting stuff is the part users hopefully never have to notice. This episode was generated by Podkey. Create your own at podkey.fm.